An alternative design that's going to allow us to move more of the business logic into our domain is going to be passing in the pricing service to the reserve method. We're then going to use this pricing service to calculate the pricing details, but the only thing that we are missing is the apartment instance. So instead of getting the apartment ID, we could be getting the apartment instance, pass it to the calculate price method, and we can also pass it to our constructor to set the apartment ID. Another thing that we can do now is setting the apartment's last booked on property to the current date and time. Currently we can't do that because we have a private setter, so we can do two things. One would be to expose a method that's going to allow us to do this on the apartment entity, and another interesting design option could be making the setter internal. So we can only set the value of this property in the domain project. And now if I go back to the booking reserve method, you'll see that this is no longer causing a compile error. The internal keyword is really interesting for adding encapsulation to your domain and at the same time allowing you to make some interesting design decisions, and this is one of them. I'm going to add a few more methods to the booking entity. The first one is going to be a confirm method. We're going to fix the compile warnings in just a moment. Then we will have the reject method, which performs a specific check and sets the booking status and the rejected on date. It also raises our respective domain event. Then I'm going to add the complete method, which is going to do a similar thing. And lastly, I'm going to add the cancel method, which contains some interesting business logic, mainly that you cannot cancel a booking that was already started. This is represented with the respective error, and we are going to introduce the concept of results and errors in just a moment. I'm going to be adding the missing domain events inside of the events folder, so now our method should stop complaining, and we need to introduce the concept of a result and errors. I'm going to add the result and error types inside of the abstractions folder, and we're going to review them right now. So the error represents something that went wrong, and we want to assign it a unique code and a name. And then we have a result object which contains two flags. One is the success and the failure flag, and we also have the error object present. Let's take a look at the result constructor. So it accepts a flag if this is a successful result or not, and it also accepts an error. It's protected and internal, so it can only be accessed from this assembly and inside of this type. Then we have some helper static methods on this type. So we have a success and a failure without an argument. Then we have a success and a failure method accepting a generic type, which is the value returned by the generic variant of the result class, and it has its respective constructor. If we take a look at the generic result, you'll see that it also has a concept of a value, which is present inside of a field and accessible through the value property. We have a rule present that you can only access the value if this is a success result. Otherwise, you are going to be met with an invalid operation exception. The only way to create a generic result is using one of the extension methods or the implicit operator, and in either case there's not going to be a chance that a null value makes it to the constructor for a success result, so we are completely defensive with our design. What is the main idea behind the result type? Throughout our domain we're going to have some situations where we are performing some checks. We could either do them in the application layer and return from there, or we could move all of this logic into the domain layer, perform the business rule checks inside of our entities, and in case of a failure, return a descriptive result object. It's either going to be successful and tell us that the business rule was satisfied, or it's going to contain an error which contains a code and a description letting us know what was the business rule that was broken. I'm going to add a class containing the errors for the bookings. The booking errors is a static class that contains the possible errors in our domain. For example, we have the overlap error, which is returned when we try to create a booking, but there's already an existing one in the same date ranges. we're giving it a unique code, so booking.overlap, to be able to know what is the entity that this is related to, and then a unique code for the specific error, and a descriptive message letting the consumer know what went wrong. How do we use them? Well, if I go back to the booking entity, you'll see, let's say in the confirm method, that we can only confirm a booking if the status is reserved. If the status is not reserved, then we return a failure result with the booking errors not reserved value. Otherwise, we set the booking status to the respective value, we set the date and time when this booking was confirmed, and we raise an appropriate domain event. With this, we completed the design of our domain layer, and the only thing that's left is to introduce the review entity. I'm going to do that behind the scenes, and you'll be able to get the source code containing the review entity as well, starting from the next chapter. In this chapter, we started from a blank solution and added the domain project where we define our core domain entities and the other abstractions that we're going to need to implement our system. I showed you some tactical domain-driven design patterns like entities, value objects, domain services, and domain events. In the next chapter, we are going to define our use cases as part of the application layer. In this chapter, we are talking about the application layer. It sits one level above the domain and is allowed to reference it, but it's still part of the application core. It doesn't have any external concerns of its own. However, there are some trade-offs that you can make at the application layer, particularly when it comes to querying the database, and I'm going to discuss these trade-offs in one of the next slides. The main concern of the application layer is implementing the use cases. The use cases are responsible for using our rich domain model, which we designed in the previous chapter, and orchestrating it to perform the business logic. We're going to use the CQRS pattern with Mediator to implement our use cases, and I'll talk about the benefits of the CQRS pattern on the next slide. We're also going to be solving some cross-cutting concerns in our application, such as logging and validation. I'm going to talk about using exceptions and when I think they are appropriate, and we are going to start adding dependency injection configuration for the services that we have so far. But first, let's talk a little bit more about CQRS. CQRS stands for Command Query Responsibility Segregation, and it's actually a relatively simple pattern. It splits the responsibilities of writing the data from reading the data into separate classes or objects. The pros of CQRS are single responsibility. Every command or query is responsible for only one thing. This is one design principle that I always try to follow because it increases the quality of your code and it improves testability. The next benefit is the interface segregation principle, which states that you should only depend on methods that you actually use. In the case of our command and query handlers, we're only going to have a single handle method responsible for handling the respective command or query. Another benefit is that you can use the decorator pattern to implement cross-cutting concerns. With the Mediator library, you have access to pipeline behaviors, which are essentially a form of the decorator pattern, or you could also call them a middleware. It's the same idea, it's just a different packaging. And lastly, with CQRS, you get loose coupling using the Mediator pattern. The command and the command handler and the respective query and query handler do not have to know about each other. The mediator is responsible for connecting them at runtime, and this is also beneficial from the side of the consumer. The consumer only needs to know about the command or query and how to publish it using the mediator. Everything else is taken care of somewhere else, which promotes loose coupling. Of course, we can't only have good things, and one of the drawbacks of the CQRS pattern with Mediator is indirection. It's harder to reason about which class handles the request. In my opinion, the pros largely outweigh the cons, and I think using the CQRS pattern with Mediator is very valuable in the clean architecture. Here's what the CQRS pattern looks like on a high level. We're going to have our API as the entry point into our system, and let's examine the query and command flows. On the query side, we have the query coming in from our API. It gets delegated using the mediator to our respective query handler, and in the handler itself, we're going to be using the Dapr library. We're going to use it to write SQL queries that we're going to send to the database. The database is going to respond with a result, and we can propagate this result from our API. This is the trade-off that I was talking about. In a pure clean architecture, you don't want to have any external concerns as part of your application layer. However, I think it's more valuable to be pragmatic and use the right tool for the job with the minimum amount of abstractions, and using Dapr in your query handlers delivers a lot of value, which we are going to see when we get to the implementation. On the command side, we have a similar approach. A command comes in from our API. It gets delegated to the command handler using Mediator. The command handlers are going to use our rich domain model built with domain-driven design and Entity Framework. We are going to use our repositories to send SQL queries to the database. This is going to return back our entities and populate our rich domain model. Then we are going to invoke the methods that are exposed on our entities to trigger our domain logic, which we implemented in the previous chapter. And finally, we're going to use the unit of work to persist the changes using EF Core, the end result being a SQL query persisting the changes in the database. Now that you have a good understanding of what fits into the application layer and the CQRS pattern, let's dive into the code and see how we're going to implement it. Let's start by defining the application project, and we're going to add it as a class library, which I will call Bookify application. It's going to be a .NET 7 project, and let's go ahead and create the project. I'm going to delete the default class so that we are left with an empty project. And now let's see what we are going to implement in the application project.